All right. So we are going to talk about files. Specifically, we're going to talk about reading and writing to files. Because, if you write programs and you don't have a way to read in data or save data, then they don't do a whole lot of good in the long run, right? So far, what we've done pretty much has been based on user input, and it runs, and as soon as you stop running the program, all your progress is lost, and the next time you run it, it starts over. So we're going to talk about files. Um, we've already talked about strings and lists. We talked about indexing and slicing and all that. That's going to be important because the simple way I'm going to teach you to read in a file is going to read it in one line at a time. It's going to come in either as a list or a string, depending on what the data in the file is. And then you have to manipulate those things. We're not going to get into very complex files. We're going to do mostly comma delimited data kind of files, like building grades, scores for games, weather data, that sort of stuff. So it'll be all comma delimited. So just in general, we're going to talk a little bit about files because I found that you guys are not great with file management. I blame Google Classroom and other auto-saving things for this because you've never had to really practice file management. It just auto-saves. Not necessarily a bad thing, but not necessarily a good thing either. So a file allows what we call persistent storage. You can write it to a file and it's there until you erase it or the file gets corrupted. We deal with all sorts of different types of files. Some of the most common ones are image files, application files like PowerPoint, Word, those sort of things. They're created by an application if you have used. And text files, which are just very simple, not a lot of formatting to them. You usually see these things in like Notepad. Now you can tell what kind of files are application files and text files based on their full name. So you give a file a name, and then the computer puts what we call an extension on it. So you'll see myfile.txt. Well, the .txt tells the computer that it's a text file. TXT is short for text. Word documents all end in .docx. PowerPoints end in .ppt. Our Python files end in .py. If you're taking my 2300 class, your bash files should end in .sh. There's a few people nodding, so. The one we're going to use in here, that we're going to use in here is .csv. And that stands for comma separated values. So your spreadsheet, like Excel, has its own application extension, but it also can be saved as a comma separated value file or a .csv, which takes all the pretty boxes out of it, and it just has numbers and commas separating everything. So it stores data. We're going to talk about the comma separated files because that's what we're going to use for our labs and assignments. So we're going to spend a lot of time on them. It's going to be plain text. There's no formatting. There's no pretty bold numbers. There's no italics. It's just simple characters. Each field or each block from the spreadsheet is separated from the next block by a comma. So we're going to split rows using our split functions from our API based on the comma, because it's going to be read in as a string, and then you're going to split it up into the pieces everywhere there's a comma. Just foreshadowing for you. Each line is a data record. So if you're in the database class, each line that's read in from a CSV file is a single record from a database or a row from an Excel spreadsheet. We talked about file extensions. The ones we have, you're going to either be given them as a .txt or a .csv. I don't remember which format I saved them in. I'll go look in a minute. But both of them can still be read in the same way and still be separated by the commas. You can create your own when you're testing your code, just by opening Notepad, putting all your data in with commas separating it. And so if you don't like my data, you can use your own. But I did give you the data files too. So this is an example of what a comma separated file might look like. This one is saved as a text file, but it's still comma separated values. So if I'm looking at this, you notice there's no headers. So it doesn't tell you what the columns are. It doesn't tell you what the row numbers are. So you have to kind of know what you're using. It's very un-user-friendly data sometimes. But I can look at this and go, well, this first section in front of the comma is obviously a US standard for how dates are formatted. So the first column is probably dates. The second column is, since the file name is steps, it's probably the number of steps for a given period, and the last column is probably another set of steps for a given period. I don't know because nobody gave me the key or the column names. So this is where I think you guys get hung up and don't know enough information. How many of you know what a file path name is? Maybe 10, 15% of the class. So back in the dark ages of computing, we didn't have these lovely things called graphical user interfaces. We didn't have Windows and Google and OneDrives with little pretty pictures of folders. We did it all by command lines. Again, this is where my 2300 class is going to go. That's why we had to do that. So all of this over here, all of this from, oops, go back. I forget that it doesn't like it when I click on things. So from C colon all the way down to .py is one file path. And then there's a second file path underneath it that's formatted a little bit differently. So the first one is the standard Windows type file path. C colon indicates your main hard drive on your computer, right? Y'all knew that you had a C drive? I hope. Classes is a folder on the C drive that I probably created, or in this case, Dr. Yoder created because it's his example, that holds all of his classes. And then inside of classes, there's another folder called CS1300 because CS1300 is one of the classes he was teaching that semester. And then he has a homework file that holds all of his homework. So now I have a folder with a folder with a folder. So we are nesting folders inside of each other. And then finally, the last one is his homework 8 file because it ends with a file extension. I know that's the actual file. Now, in my life and your life, you probably navigate this visually by clicking on the file folder at the bottom of your Windows screen, and it opens it up and it visually shows you the names of all the other folders, and you double click and it opens that folder. But when you're writing code, your code can't go visually open up a file folder and look at it and pick the right one. You have to tell it where it's located at. And a lot of times you're writing code that's not going to know the file structure of the computer it's running on because it's written by somebody else. So you're going to use some more generic path names to get there, and we'll learn a little bit about that. But I'm going to suggest heavily to everyone that you spend some time thinking about path names. Maybe go watch a YouTube video or something if you don't understand how path names work. Because it's going to come back over and over again in other classes. If you don't believe me, ask some of the ones that are sitting in here after having taken other classes. I don't know. Are y'all using path names in database? Attached to each other? Not yet. Oh, y'all using a graphical user interface. Okay, so probably not. I don't teach that one, so I don't know. So think about it. So, folders can have folders, When I was teaching high school, I'm going to be honest with you, one of the best pranks I ever saw, and I laughed really hard when the class wasn't looking at me, was that we all shared computers, and no matter how many times I told them to log out before they left, somebody invariably would leave their computer logged into their account. High schoolers. And I had two friends that were in back-to-back classes, and they sat at the same computer, and one of them was annoyed with the other one that day. So he took his Java project that we were working on, and hid it in 36 layers of folders. And he named every folder basically the same thing with just a slight variation on it. Yeah, or change the number or something at the end. And the person had to click through all of them to find their document. Actually, they didn't, but they didn't understand file structures and how to use the file either, because they could have used the search function and not had this problem. Right? But anyway, I found it hilarious. I didn't tell them I found it hilarious. Yes, I had to punish them for it, but I did use it as a teaching lesson on how to teach them to use the search function and the file folder. But also remember, anything you save on your computer, it's not really gone until you put some effort into removing it from your hard drive. And anything you put on the internet is never really gone. Somebody's going to be able to find it. So don't put anything out there you don't want people to know about yourselves. Just the mommy in me telling you. Because you'd hate to be going up for your first job interview and find out that the company HR person Google searched you in your social media. They do. Companies do it now. So be aware. So this file path right here points to this one folder no matter what. It's going to follow these directions. It's like the GPS is locked and you can't make any deviations. It's going to start at C and it's going to jump through every step. It's a permanent address. We don't necessarily want to use hard fixed addresses when we're writing code because we don't know everything about the computers they're going to be running on. So there's some shortcuts you can use that indicate up a directory, down a directory, or in this case, up a folder, down a folder, that sort of thing. So that's when you see the dots. This one assumes that you're already in the CS 1300 folder, and it just needs to find homework and the file. 2 dots assumes that you need to go back a folder to look for stuff. Now, am I going to make you memorize all this in this class? No, but be aware that it's going to be added to this class. That's why we're using the people that take this class after you are going to start seeing more of this added into the class. But I need you to be aware of this, because the stuff we're fixing to do, if you do not save your .py file and your data file in exactly the same folder, you're going to have to know how to do this where it can look for it. Yes.
Like for and that, like paths don't exist. Just got a jumble of folders. Okay. There's no such thing as C on Mac.
Yeah, if you're a Mac user, a lot of this is not going to make sense to you, because Mac likes to pretend that it's the only thing out there, and that path names don't really exist. They don't call their hard drive a C drive. They're special and they know it. I am not overly helpful with Macs because they frustrate me, because they don't work the way that every other computer in my 30+ year history of working with computers work. But hey, we can find somebody that can help you if I can't figure it out. Because several of the professors upstairs are Mac users, but I'm not. So we're going to be talking about the open function, because we're going to open a file and read from it. So like any other function that is getting data, like the input function, we have to set up a variable to hold the data we're getting, right? So the first thing we're going to do before we open a file is we're going to set up a variable to hold what we're opening. So step data is going to be equal to open steps.txt, comma, R. Now, the comma R indicates that we are read only this file. Can I put read write in there? Yes. Should I? Not unless I'm planning on writing something back to the file, because you don't want to corrupt your data. So right now, we're just going to read it, because we just want to read it in and play with it. We don't want to change it. Yes.
That's good.
Oh, yeah. So it's going to open the file. It's going to read only the file. When we're done with the file, we need to implicitly tell it to close, or it's still running in the background of the file. So you will need to put the close command in once you've done reading the file. If you don't, I will dock you points for it, because it's important that you learn to close your resources. Will it make a huge difference in what we're doing? No, because the files are so small, it's not really going to eat up that much memory that it's still accessing it, but it could in larger applications. So once we read that in, it reads it all in as one great big string. You would have 1 million records. It's coming in as one string. So the first thing we have to do is separate that out into lines. And luckily enough, when it reads that in, it also reads as a return character, which is not shown in the file, but is there in the background. So there's a /n at the end of every one of the lines in your file. So we can use that as our character to separate things by. Is files reading? Absolutely. So we can use a loop to do this. We can set up a temporary variable called current line. And for each line in step data, it'll read it in, right? And if we do this, it prints each line. It's touched everything in there and it's printed each line. Because the file does know where the return character is. We also can take each one of those lines and we can split that line up using the split function from when we were doing strings. It's in the API, but we'll talk about it some more in here too. So I've got a single line from a comma separated file, but I only need one piece of information on that line. So I'll have to split the line. So if the string is A, comma, B, comma, 2, comma, 4.2, comma, dog, I have 5 pieces of information on that line. And let's say I only need one of them. To be able to access it easier, I'm going to convert it to a list. Because if I take that comma separated data and I put each line into a list, now I can look at each line individually and I can grab data based on its index number because lists index piece. Right? Are there better ways to do this? Yes, but I haven't talked to those. So this is what you have. So values is going to be what we call the value, the line. I'm going to do my string dot split. I'm going to split on the commas. The split knows what that means. You give it whatever character you're splitting on. If it's not a comma separated field and you wanted to split on a space, you put the spaces. If you wanted to split it every time you saw an M, put an M in there. Don't know why you would want to do that, but you could do that. When I do this, now values is a list and I can index it, or it is indexed. I can access any piece of data in that list one at a time. So I could find out what animal is on every row by using 4, the index of 4, right? Because there's 5 pieces of data, so it's 0 through 4. This makes sense? Some of you are just staring at me, so that doesn't help. All right. I'm going to keep going until you ask me a question. So in this example, we have step data is equal to open steps.txt. We're going to read it only. We're going to loop through each line of that file we just read in. We're going to then take each of those lines and split them into a list. And from that list, I'm going to print the second item, because index of 1 is the second item in the list. And then I'm going to close the file because I'm done with it. So basically, that would take a whole file worth of information, and it would print out everything in the second column of the file. This is important because your project coming up, you got a project where you're going to have to sort temperatures out of the file. One column is the date the temperature was taken. One column is the low temperature for that date. One column is the high for that date. And you're going to write code to find out different things about the low, the high, and the dates those happened. You can build a list from the file. Because once you declare it and start splitting the file, it starts off with an empty list and it just each line gets added to it. I gotta remember, I gotta stay up here where the microphone will pick me up. I'm not used to having a column where or row where I could walk down that middle of the room. Just be careful when you're doing this to remember what the columns are supposed to be and try to keep your indexes sorted correctly. This is where using useful variable names are absolutely going to be a good idea. They're going to help you immensely make you, even if they're really long to type, having clear and concise variable names when dealing with this much data you're reading in, it's going to help you in the long run. Remember, lists can have different types of data in them. So I just told you how the file was read in as a string. And the list we created was of one row from that file. It's still all string data. So those numbers are still strings. So when you get ready to do something with them, you're going to have to convert them either to floats or integers if you need to do math. So you're still going to have to do some type conversions for data that has been read in from a file, because the way we're doing it, it's all coming in as strings. And pretty much that's all of the file stuff that's new. And I think it is easier to understand once we start writing the code for it. I am going to strongly suggest, if you haven't already, go do the reading for this section, because you need to see it as you're reading it. You need to, the book has some places in it that'll let you do some examples. Wouldn't hurt to try some of those. Also, I will do the entire lab with you in class again on Thursday. Just like always, I will record it. I've already got it posted. I got the data files posted to go with the lab and the assignment. But I need you guys to really understand what we're doing this week, because next week's project heavily leans on this. It leans on the other stuff we've done. You're still going to do loops. You're still going to do functions. You're still going to do conditional statements. But you've got to really understand how the file reads in and how you break it down. The rest of the project's going to go forward. Questions? Concerns? Yes. Catch me after class then. Yes, ma'am. A week. Anybody else got a question? If you need to see me individually after class, I'll stick around until class is over. I know we got done pretty early, but we're only reading files. We're not writing files this semester, so we don't have to get into the complexities of writing the file.